This is section 12.1 in exponential functions, and our objectives are to evaluate exponential functions and graph exponential functions. And a lot of this stuff we're going to be using a calculator for. So on the problems, I'm going to show you what buttons you punch in the calculator in order to get the answers. And then when we're in class, I'll show you on the board how to actually do it. I can't actually put the graphing calculator on this thing. I wish I could, but not right now. As of right now, I don't know how. So the steps for evaluating an exponential function is to just substitute the value in for x and evaluate. That's what we're going to do first, is just evaluate them. So we have evaluate this function f of x, for example 1, f of x equals 42.2 times 1.56 to the x. And the power is the variable in this case. That's what makes it exponential, is when the x is in the variable. Or I mean when the x or the variable is in the power. And so it says find f of 4, which means we're just going to plug 4 in for the x. So we get f of 4 equals 42.2 times 1.56 to the 4th. And you just punch that into the calculator, and what you get is 249.9. And I got to write real big because my pen just is not working, so I'm going to do the best I can with my finger. Let's pause here, try the checkpoint. When you come back, I'd give you the answer. Okay, checkpoint 1, it comes out to, for f of 5, comes out to 389.9. Now, graphing. Next is graphing. In graphing, we are going to make a table choosing integers from -2 to 2 and plug it into x and find the value of y for each. And then plot the points to make the graph. And the general graph of an exponential looks like this curve right here. And it'll come down to an asymptote, which in this case, for this one, we got y equals 2 to the x. This number could change. It could be 3 to the x, 4 to the x, and that just changes how steep it is. As long as we're not adding or subtracting anything to it, it'll always go through 1. And if this is a 3 or a 4, it just makes this steeper. But in this case, y equals 2 to the x, you get what's called an asymptote. And it's spelled like this. Asymptote. And that would be the line y equals 0, or the x-axis in this case. Now that can change depending on how this graph shifts. But for this graph, for the y equals 2 to the x graph, the x-axis or the line y equals 0 is the asymptote. And what the asymptote means is this line, this curve, gets closer and closer to the x-axis, but it never actually touches it. It just keeps getting closer and closer to it. And it goes on to infinity out here. So we're going to graph them by making XY charts. And you know XY charts, they're just the charts like this. We're going to plug in -2 to 2 on all the charts. And then we'll plug it into the equation, in for x, and find out what we get for y and fill in the y's afterwards. So let's look at a problem. Alright, so example 2 says f of x equals 2 to the x. And when we are graphing this, we would go to the y equals button, and we would say 2, and we'd use the caret button. And that's how you'd punch it into the calculator, 2 to the x. You'd have the y, probably do it under y1, and you plug in 2, then the caret button, and x. And so we're going to make our chart, xy chart. And we're going to do -2, -1, 0, 1, and 2. And you're going to have graphing calculators, so I'm going to be able to show you tomorrow, if you don't remember, how to get to the table on the graphing calculator, and it'll give you all the answers from -2 to 2 when we actually graph it, when we plug it in. And so what we're really doing is plugging in -2 in for this x and seeing what the answer is, and that's what our y is. So we get, for -2 is 0.25. -1, when we plug that in, that's 0.5. 0 is 1, like we said it was before. 1 is 2, and 2 is 4. And so if we graph this, we've got to go from -2 to 2. And this is not going to be the easiest thing in the world to graph. I'll try to use a different color here. -2 is 0.25. Hold on, let me put the verticals. We've got to go up to 4. So you got 0.25, which is going to be real close. And then you got 0.5, which is going to be a little higher. And then you got 1. And then at 1 you got 2. And at 2 you have 4. So my graph would look like that. And it would keep going in different directions. And again, my asymptote would be the x-axis. So let's look at B and see what happens when we have a fraction raised to an x. And if we were punching this in the calculator, we would be using parentheses, 1 divided by 2, and caret, let me slide this over a little bit, to the x. So that would be how we'd punch it into the calculator. If we were doing an xy chart for it, x, y, we're going to do -2, -1, 0, 1, and 2. And if we plug those in, and again, the calculator will give us the answer. I'll show you on how to do it with the table. It's going to be 4, 2, plug in -1, we get a 2. Plug in a 0, we get a 1. A 1 is 0.5, and a 2 is 0.25. And you can see it's going to be kind of reversed. So we got -2, -1, 1, 0, 1, and 2. We got to go up to 4, 2, 3, 4. Let me make that a little better. Okay, so -2, we're going to be up 4. I'll do this in blue again. -1, we're at 2. At 0, we're at 1 again. And my dots are a little off. Like I said, my pen's not working. At 1, we're at a half. And we're at 0.25, which is real close. And so the graph would look something like that. And you can see it's reversed. So when we get a fraction raised to an x, a fraction exponential graph, the curve is going in the reverse direction. The asymptote is still the x-axis, though. And that's not going to change until we start shifting up and down. So try checkpoints A and B. And actually, I think what I'll do, I'm going to save these checkpoints. I'm not going to give those to you. We'll try them in class. I'll go through those in class and show you how to do them with the calculator. So skip checkpoint 2 right now, and we'll go through those in class. So let's look at example 3. Whoops. I want to move it up. Example 3, Now we have f of x equals 2 to the x plus 5. And if you remember, this is considered the inside of the function. It's the inside. And if you also remember what the inside does, the inside shifts the graph left or right. And so this would be our regular 2 to the x graph, but we're going to shift it to the left because it goes opposite. Plus 5, you would think it would go right, but it's the opposite. So this is actually going to shift 5 units left. And so it's really going to be the 2 to the x graph, but it's going to be shifted 5 units to the left. Which means we're not going to want to use the same numbers for our x. Our xy, we're not going to want to use -2, -1, 0, 1, and 2. We're going to want to use 5 less than that, since it's moving left 5. So we're going to take 5 away from each number. So if we take 5 away from -2, we're going to use -7, and then -6, -5, -4, and -3. And that's a terrible 3. But what that does, since it doesn't shift vertically at all, we're still going to get the same heights as we did if it was -2 to the x. So -7 would be our, if we looked at example 2, the top number is 0.25. That would go with your -2 on your example 2a. And then you got 0.5 for -6, and 1 for -5, and 2 for -4, and 4 for 3. So everything's moved over to the left 5 units. So we got to go to 1, 2, 3, 4, 5, 6, 7. -7. 1, 2, 3, 4. -7 is our 0.25, and I'll do it in blue again, real close to the x-axis. The -6 is 0.5, a little higher. -5, we are going to be at 1. -4, we're at 2. And -3, we are at 4. So it looks very similar to the graph of example 2a. It's just shifted left 5 units. Let's look at B. 2 to the x plus 5. Now this is the outside. And remember, outside the function shifts up and down, and it shifts in the direction you think. Plus 5, we're going to be up 5 units. I can't spell units, or I can't write it anyways. Did it again. Units. This is an N. So that's going to make things different. We're not moving left or right now. So we can still use our -2, -1, 0, 1, and 2. Well, let's do that in black. -2, -1, 0, 1, and 2. Because we didn't move left or right. And so if we're going to stay in the middle, we're just going to move up 5. Well, that means -2, it's still going to be regular 2 to the x graph, but it's going to be moved up 5. We're just going to add 5 to each one of those y's. So -2 would be 5.25. And then -1 would be 5.5. And then 0 is 6. 1 is 7. 1 up from that. And then 2 would be 4 up, so it is 9. Let's graph that. We'll need some spot up. We got to go up all the way up to 9. We're going to go -1 and -2 and 1 and 2. And we got to go up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 2 is 5.25. So 1, 2, 3, 4, 5 and a quarter. We're going to be real close to that. Wait, let me recount here. 1, 2, 3, 4. So real close to that 5 mark. And then we got to do 5.5 for negative 1. And then 6 at 0. And then 1 for 1 we're going to be at 7. And for 2 we'll be way up at 9. And this is what it looks like. And again, we're going to do the checkpoint in class. So leave that checkpoint alone and I'll show it to you in class. And I will give you your assignment on Monday or in class, in the next class.